the two maybe most important questions out of the series of questions. So now we want to figure out the percent by mass of the Br in the original XBr compound. So let's find the percent by mass of Br in this compound. Well, notice we have the original mass of XBr, and there it is. We put it into the solution, it ionized, we add the aqueous silver nitrate. The silver nitrate, the silver precipitated out the Br minus, so the Ag positive precipitated out with the Br minus, making this solid precipitate, and then we do have the mass of that. So let's see. So percent by mass is going to be the percent by mass of this. The formula would be XBr, the mass of that in grams, divided by the mass of Br minus in grams, times 100%, and that would equal the percent Br in XBr. Now, of course, there it is. Now, of course, then we could, once we know the percent by mass of Br and XBr, then we could compare that percentage to maybe percent by mass of lithium bromide and see if they matched, and then maybe percent by mass of sodium bromide and see if they matched. Who knows, it may even match up to like calcium bromide, which is, so there we'd have an alkaline earth metal. Sorry about that. So notice it could be, X could be any one of these. And again, once we figure out the percent by mass, we could easily do a quick percent by mass of these and compare. So notice here, we have this value already. So let's write it here. You have 0.161 grams XBr. So really all we need to find is this gram quantity of the Br minus, and then simply times it by 100 and we're done. Well, let's see what we're given here. So we're using this quantity already. Now we do know the mass of the silver bromide precipitate. And we know that all the bromide from here is now locked up here. Why do we know that? Because we added excess amounts of silver ions. We still have positively charged silver ions flowing around with no more Br minuses left to react with, or very insignificant amounts left to react with. So, can't we determine the mass of the Br in this compound? We can do that a couple different ways. Let's take a look at that. Here's our mass of XBr. We need to find the grams of Br, but we have to do it indirectly. And we need to determine the mass of the Br present in this AgBr sample that we collected, filtered, and dried. Let's take a look. Notice there's my collected sample of the silver bromide precipitate with the mass. The percent by mass of bromine. Notice what I did. I did a percent by mass of Br in silver bromide. So there's the molecular mass in grams per mole. Grams per mole cancels, grams per mole cancels. So there's my mass of the bromide, times it by 100. So I've got 42.54% Br by mass in silver bromide. So we do a little simple math. There's my mass. Let's figure out what 42% of this value is, approximately 42%. Convert this to a decimal. So now we have the percentage to a decimal. And, excuse me. And then we simply times it by that mass. And that's the amount of the mass of the Br in AgBr. Eureka, we found it. So at this point, it becomes pretty straightforward. So let's just add in 0.1481 grams, times it by 100%. And that's grams of Br. So if you can't read this, here it is, 0.141 grams of Br divided by 0.161 grams of XBr times 100. And when we do that, we're going to get 91.99% Br by mass. So here is our percent by mass. Now notice we didn't ask to do this, but maybe on the next test or on the final exam, we could then compare this percent by mass of Br in XBr, and then compare it to the percent by mass of bromine here, 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 and then we've identified that unknown ionic solid. So, there's my calculation, and there's another so. Is there another way to figure out the mass of the bromine in AgBr? You bet your bippies there are. There is, anyway. So, let's take a look. There's my mass of solid dry precipitate. Let's convert grams to moles of AgBr. There's the fun part. Let's go from moles of AgBr. For every 1 mole of AgBr, we have 1 mole of Br based on this 1-to-1 ratio. Then let's convert moles of Br to grams of Br. So there's my molecular mass, and notice there's that 0.148 value that we used. Either way is fine. So here is the data for number 6, the percent by mass of Br minus in XBr. Again, we went through this, but here it is kind of summarizing. So notice we have 0.161 grams of XBr originally. That was the original mass. Here is the mass of the Br that was in the precipitate. So this was in the silver bromide precipitate that we had to indirectly determine. And then, of course, times it by 100. And there's a close approximation of our percent by mass. Notice, if you're being a stickler for sig figs, we have 3 digits here, and I got that data from the question itself, and then 4 digits here, so this actually could be rounded up, where you'd have 3 sig figs. So we could make that 92.0. Anyway, let's look at the last question. Suppose the filtered precipitate is not completely dried before measuring the final mass. Would this increase, decrease, or have no effect on our final percent by mass calculation? So let's reason this out using our formula for percent by mass. This is the percent by mass formula. We have the grams of XBr, and then we have the grams of Br times 100%. All right, here's XBr. That was given originally. Here's our mass of Br that we got indirectly by determining the mass of the precipitate. So this comes from the precip. All right? The precipitate is wet. So instead of this being 0.1481, maybe it's 0.3082 now. So really what we have here is the mass of the bromine plus the mass of the small amounts of liquid water. So that increases, the numerator is now increased, and that means your final answer is increased. Now maybe we're at 99%. That's a weird number, 99% BR. Weird number, but it's not a valid number because we actually have a mass here of the BR plus some liquid water that wasn't completely dried. So boy, we're confused, or we turn that in and we're way off. So there you have it. I hope this was helpful. Have a good day.